Good morning. I'm Gianluca. I'm a career track research at Berkeley National Lab, and I'll share a little bit about Drishti and HDF5 in specific context. And this goes along with what we've been talking so far of what is my application actually doing? Is it doing what I'm expecting it's doing, or where is the problem, or how things are working underneath it? So this is a work that we are doing in collaboration with Suran and also Hamad, who's back there. And I'd be happy to talk to you about some of the next things that we're developing for Drishti. So let's get started. We all know that the HPCIO stack is fairly complex. We know we have using it properly and in the best way possible is very tricky. We have several factors that can affect performance. We do have several optimizations that have been created by the community over the years, tackling each one of those specific layers, sometimes multiple layers at a time. And all of those optimizations also bring their own set of parameters that can affect performance. So how can we make sure as an application developer or as a user that whatever I'm doing on the upper side is actually what's happening on the storage system? Let's say, for instance, I'm reading or writing large requests from my application. Is it that what actually happened down the road? How all of these different optimizations that are applied on all of these layers transform my requests as it goes down the stack. So what can we do to get a little bit more information on what's going on there? Maybe we can use metrics coming from different profiling or tracing tools. One of them is Darshan. I think most of you are fairly familiar with it. Darshan, basically, it's a profiling tool which will provide some counters and metrics about how many accesses you're doing, how many reads, writes, opens, what are the distribution of the request sizes, and all of that. There is an extended part of Darshan, which is called the DXT module, which kind of works like a trace tool, which will provide a much more finer grain detail of what's going on. So we can think, instead of aggregated numbers, we're looking at what's happening on each of those requests. There are other tools to also tackle this, like Recorder, Tau. But good, we have metrics. And then what? So how can we make sure that having the metrics, I can see where my problem is? And more specifically, how can I use those metrics in my favor in order to apply the correct optimization techniques to solve the problems I'm seeing on my application so that it can actually perform better? So we know there is a gap between all of this profiling or metric collection tools and the actual tuning process of the application. What we're interested here is how to convert those metrics into something that is actually useful and meaningful so people can act upon them and make changes to the application, to the configuration, or to any of the parameters on any of the knobs that they have available throughout the stack. So what we are looking here is ways to visualize characteristics, behavior, and bottlenecks that my application is suffering, be able to detect where the problems are corresponding to any of the layers, or is it something that goes based on what my application is doing when expressing its data or expressing its access, and then map those problems, things that we are finding, into solutions. Say, oh, this is a couple of techniques that we could use in this case that could benefit the application, and then guide users to do that. So to close this gap, what we are working on is Drishti. Drishti is a Sanskrit word that means point of focus. What we want to do with Drishti, and a couple of you might have heard of our initial efforts in this. One of those was the DXT Explorer, which is more of the visualization part that we presented a while ago in PDSW. We had the Drishti original version, which was only focused on recommendations. Now Drishti is encompassing both, and it's going to be much larger than that. So it's not only being able to interactively visualize what my application is doing, but also pinpointing the root causes, detecting the common pitfalls, and providing the actionable recommendations. So we are looking at a much broader scope from the metrics up to the tracing and providing that information to the users. We're also working to support other sources of IO metrics. Those can be from Recorder, can be from other tools as well, or even the file system, if those are available, in order to provide much finer grain detail, more certainty on the recommendations that we are giving to the users. Here we have an overall view of how Drishti roughly works. So we have our application on the first side there, collecting all the metrics, even using Darshan or Recorder. It depends on the setup that we have there. And what happens inside Drishti is we do have the interactive plots that I'm going to share with you in a couple of slides on how to visualize different aspects of my application. We have some analysis that is being done in order to detect behavior, detect IO phases, and the insights. So based on common problems that the community has seen so far on this is bad for application, this is something, as Harry mentioned, maybe stupid that the application is doing. What are the things that we can tell the user to try out instead so that he avoids those common pitfalls? And then we combine all of this information into those interactive plots that can focus specific on operations, on transfer size, on the speciality, so how those requests are distributed in the file, in the IO phases. So let's consider an IO phase here, a specific period of time where the application is doing some request, either with the same size, same speciality, same number of files throughout, and how that repeats throughout its execution, and also some visualizations on the storage system side, if those metrics are available. So this is the overall idea of the Drishti, which is encompassing everything from visualization to recommendations. Talking about interactive analysis, so this is the first component. Here we have some of the example plots that Drishti can generate. So for each file, in this case, Drishti so far has been heavily focused on the Darshan, either the metrics overall or the DXC traces. For the specific visualization here, since we're looking at all the operations happening throughout time, we do need the DXC information available. And from that, you can generate like multiple plots. So the first figure over there is like an index for each one of the files that the application is working on throughout its execution. We can visualize those files through different lenses, through the operation, transfer, and speciality plot. So the operation plot, you're going to see we have two boxes, one of them representing a much higher level, which is the MPIO, and then POSIX. And you can see, for instance, in the large blue box there, which is a collective operation on the MPIO side, how that is transformed and applied into POSIX when the request actually reached the file system. So that gives us an idea that not always what we assume the application is doing is what actually happened. So we can look at that same plot for transfer sizes. So we can take a look and have hints on where my operations. So just to give an overall idea, this is an HDF5 based application. So it uses HDF5 underneath. You can, from the transfer size, take a look and see where possible metadata operations are actually happening. And that was something that helped us apply different optimizations that were targeted for the metadata part of the application in order to push that to the end, doing it in a way that improved performance. We also have special locality plots, IO phases plots, as I mentioned, and the OSD usage throughout the execution. And all of those plots are interactive in a way that you can zoom in, you can select a subset of ranks, you can get all the contextual information. So what is the rank, starting time, the offset, the OST for that particular request as you hover over those plots. So we do have the interactive analysis part, but now how can we detect the common pitfalls? And for that, we have triggers, which we have aligned in 4 different levels. So the high level ones are, there's a high probability that will harm your application. We have the ones that are under warn, which is those could cause a significant impact, but we cannot be certain at this point because we do not have metrics that would make us more assertive in their impact on performance. So this is something you may consider, take a look and see, maybe this is actually impacting my application. Okay, if the best practices come from what the community has seen over the years, those have been followed, or just relevant information in terms of how your application is actually issuing the requests. So I'm going to share two test cases, two use cases that we use throughout the development of both the DXT visualization part and the Drishti recommendation part. One of them is the WarpX OpenPMD application, which I won't go into a lot of detail about the OpenPMD part because I know Axel is there and will give us a presentation in the following days. So feel free to reach out to him to learn more about it. But here's a couple of executions we had. This is on Cori. On Summit, we also made some tests and we got, if I recall correctly, roughly 6 or 7 times the speed up just by optimizing things that are HDF5 related. So on the first side there, we have the baseline execution. You can see the red parts are the metadata operations happening throughout the execution. On the right side, we have sort of pushed all the metadata operations and increased the request sizes. Those were some of the recommendations that came from Drishti's report. So those insights right at the bottom sort of indicates what is happening. Some are quite obvious for the community, like avoiding small request sizes or making sure those are aligned, or even mostly doing consecutive or sequential reads and writes. So those are things that Drishti, based on heuristics, will trigger for a given execution so that we can get more details about it and optimize. Drishti will also generate reports in, let's say, 3 verbose modes. One which is just triggers, the other one which will provide recommendations on how to fix them, and the third one which actually provides some code snippets so that you can have a roughly idea on how to implement or change your code to fix that problem that we were seeing there. So in this particular case, as I mentioned, those red ones are the ones that have most impact. And that's the ones that we try to optimize and got that specific result. The other test case is MREX. It's used in several different contexts. I'll show just another test case here, again on Cori, before Cori was retired. And what we saw here, as you can see, it's pretty much more things going on there. The original version had several problems in terms of all the files it's accessed, some of the things that were supposed to change, including, in this case, using the asynchronous wall connector to hide some of the computation that was happening between the data writes. And on the right side here, where we got the 2.1 speed up, you can see how Drishti, the final report we have after optimizing the application with all the suggestions. So some of the things that are coming soon, we are working on improving the recommendations. As I mentioned, those are heuristic based, but we want to be able to also pointing those back to the source code and tell the user, oh, this is where on your application you need to make changes, because this is where it's causing Drishti to trigger that specific issue, enhancing those code snippets, and also adding other sources of logs from recorder or file system metrics, and adding more complex triggers. So to wrap things up, pinpointing those root causes of performance problems in terms of I/O does require us to have detailed metric analysis and requires us to have an understanding of the complex stack. And what we are trying to do with Drishti is close the gap between the trace or metric collection, the analysis, and the tuning, so users can have their applications run faster by detecting those normally root causes of performance inefficiencies and telling them what are the actionable items they need to take in order to improve performance. Thank you.
Thank you very much, Julian.
Thank you.
Questions?
Do we support that work with just single process tools, or could you look at multiple processes running on one system?
You mean like MPI-based applications, or?
I'm not as familiar with the scientific side, but we're using the HDF5 library. We have multiple processes running on a single system. So behavior of, I guess the behavior, how well that system is performing with respect to the use of that.
Yeah, if I understood you correctly, I believe we can, as long as you have the Darshan traces enabled on the system. And Darshan can work now with both MPI applications and non-MPI applications to collect those metrics which are required for Drishti. Or you can even use Recorder, which is another thing that one of our students is working on, so that we have different sources of data that can be used by Drishti.
I have a question about the overall analysis and tuning. Will that be like, I guess most of the time we're just offline connecting to the matrix and analysis. Is that possible to do that online?
So at this point, everything is offline. To do that online, I think it is somewhat possible. There are some things that you can influence during runtime, some things that can be tuned during runtime. Other things are sort of hard-coded in the way that the application is actually accessing its data. In terms of Darshan, I know it does have some way of collecting or extracting that information during runtime, so it can interface with other applications. It could be interesting in one case to provide those insights. But that's definitely something we can consider doing in the future, so that we can be more proactive in a way than doing everything offline post-mortem.
I was going to say, go back to the slide that you showed the initial stack on my feed. Before that. But I'll just ask a basic question. If you all recall, you had a slide that said the IO stack is complicated, and you layer there's many layers. And you're talking about an approach that goes into the bottom, looks at the bottom of that stack and all the activity that's happening at the bottom. And I guess I have to ask, since each of those layers is basically impacting what the activity is happening there, why isn't the real answer to go up to the application and sort of analyze the application to understand what it's really trying to do, and then figure out how to make that basically do its work faster?
So that's somewhat what we're doing. So Darshan will capture what the application is doing at a higher level side, and we'll capture everything that goes through different interfaces. So let's say the application uses HDF5 with underneath uses MPI, that those requests are going translated to POSIX, which reach the file system. So we do have a view of what's happening at the MPIO level and the POSIX level. We don't have the detail counters from the HDF5 side on, at least for the DXT module on Darshan, in order to have the full detail of the stack. But we knew, and also sometimes we don't have access to the file system counters, which could correlate through the entire thing. But what we're doing right now is taking a look at the middle part, let's say the MPIO side, which represents much higher level of the stack, and the POSIX, which is so much lower.
But Recorder give you HDF.
Yes, Recorder does, and we're working with one student to add support to that. So even those plots will contain HDF5 related information, so that we can have a much better view of the entire.
Yeah, that was kind of the direction I was going to. You know, could you make a vol connector, a pass-through vol that emitted the Darshan info? It's straightforward, I would think.
Yeah, that's something that we can consider doing. I think that would be very helpful for a lot of them.
It's totally straightforward, yeah.
Yep.
And the next step is, can you talk to him, right?
Absolutely.
Can you put the JSON file to fit into the intent thing?
Absolutely. I mean, we can use the intent in order to provide some other recommendations on things that could be optimized based on the application is going to have to use, considering like workflows and those kind of stuff, where not necessarily what the application is doing right now is the best for what's coming next in terms of format, in terms of way of accessing files. So that could be integrated as well. Let's have a chat on that.
Thank you.
Thank you.